All right, so today we're looking at section 4.2. We will spend 2 days on this, reviewing just that idea of logs and how to go from log to exponential form and back and forth. We're going to look at evaluating some basic logs and looking at some of our log properties today. And then tomorrow we'll tackle the last couple here. Logs are related to powers. So again, if you want your power chart out, you can certainly have that out to access. So for a logarithm, if you remember from last year, logs are used to solve for exponents in an exponential equation. The answer to a log problem is really just an exponent. So that's something you really have to keep in mind. When you're looking for the answer to a log, that is your power. You're trying to find the power that's being used. When we read a statement like this, we read it log base b of x. And the biggest thing is to understand, how do you go back and forth between log form and exponential form? This is log form, and this is exponential form. These two statements are equivalent. All right, if I say y equals log base b of x, that's equivalent to saying that your base to the y power will get you to x. When we've taught it in the past, we kind of do a little circle thing. You remember that? You start with your base, you raise it to the y power, and you should get back to what x is. Okay, so again, being able to go back and forth between those two things is very important. When I look at a log form statement, I'm always asking myself, my base to what power will get me to an x? So for this first chunk of examples, we aren't solving anything, we're not evaluating anything, we are simply going back and forth between the two formats. So if it's in log form, we want you to switch it back to exponential. That's what we have in this first example. So we always start with our base. What's our base? 5. So we start with our base. The answer to your log statement is your power, which means in this example, 2 is the power. So we are saying 5 to the second power should get us to x. Again, think of doing that little circle. Okay, your base to the power should get you back to x. So in the second example, we would start with our base to the y power should get us to 7. Example 3 is already in exponential form. We are going to convert it back to log form. So what is the base of this exponential statement? So we would say log base 12 of something equals our power, right? The power is always the answer. So our power is 2. So it's got to be log base 12 of x equaling 2. And you can always check it, do your circle. Do you get back to what the other statement was? Okay. Example 4. Our base is b. So we're going to say log base b of what? Log base b of, what are we missing? What is it supposed to equal? It should equal the 3, right? It has to equal your power. So the only other number that we have left is the 8. So log base b of 8 has to equal 3. We have one in log form, so we're going to do our circle to rewrite it in exponential form. Our base is b. It's being raised to the third power, because remember the answer in your log is your power. And we should get to a 64. So yesterday we talked about e. We called it our natural base. Okay, so we have e to the y power equals 9. That would be log base e of what? Log base b of 9 has to equal y. And there's another way to write log base e that we're going to be talking about for today. We'll just leave it like that. I'm going to pause the recording, give you guys some time to try this next chunk, pair up with someone, and then we'll check in a minute. All right, let's check. What did you put for number 1? All right, agree, disagree. So 5 to the 3rd power should get us back to an x. All right, number 2. All right. Question 3 is already in exponential form, so we have to switch it back to log form. So we would have log base 2 of equals, all right. Question 4. Log base b of 27 equals 3. Good. And number 5. It's in log form, so we can just do our little circle. So 4 to the y has to equal 26. And the last one. Log base e of 33 equals y. All right. Any questions on going back and forth between those two forms? So sometimes we can actually evaluate a log statement. Sometimes it's going to end up being a decimal. But we have those perfect ones that work out. If we picture this one being some unknown, right? We're being asked to evaluate log base 2 of 16. So we're really being asked 2 to some power should get us a 16. Right? When we evaluate a log, we're trying to find a power. So 2 to what power gets us 16? Is this a perfect one? Can we raise 2 to a nice integer power and get a 16? Yes. What would it be? A 4. So our answer here is just 4. All right, same thing here. 10 to what power will get us to 100? 10 to what power gets us 100? 2. So our answer would be a 2. "25 to some power gets us a 5. Now that one might seem backwards. What do we have to do to a 25 to get it to be a 5? We have to what? Just in general. Don't tell me a number, but in general. What are we doing to 25 to turn it into a 5? We're square rooting it, right? What's the exponent we use for a square root? 2 is used to square. What's used to square root? A 1/2. So anytime you're going from a bigger number to a smaller number, you're taking some kind of root, which means your answer is going to be some kind of fraction power. So in this case, we were square rooting, so our answer would have to be a 1/2. Okay. 7 to some power gets us 1/49th. Okay, 2 things are happening here. What do we do to a 7 to turn it into a 49? We square it. What do we do to flip it and make it 1/49? We need a negative exponent. Negative exponents are going to flip it. So if you're going from a number to a fraction or a fraction to a number, you have to flip something. It's going to be a negative exponent. So in this case, our answer would be -2. We have to flip it and we have to square it. Okay. Looking at the next one. 2 to some power is supposed to get us the 5th root of 2. But how can we write a 5th root using an exponent? 1/5, just like a square root is a 1/2. A fifth root would be a 1/5. So 2 to the 1/5 is going to be the fifth root of 2. So our answer would be 1/5. All right, I'm going to pause the video. I want you guys to try the next 3. All right, 5 to what power gets us 1/125th? We have to flip it, which means what kind of answer? Negative. And it's going from 5 to 125, which would have to be a cube. So our answer would be -3. Okay. Number 7, 36 to some power gets us a 6. Similar to the one right above it. What are we doing to 36 to turn it into a 6? Square root. Any kind of root is a fraction power. In this case, square root would be a 1/2 power. And then for the last one, 3 to some power gets us the 7th root of 3. How can we write a 7th root using a power? 1/7. Okay, questions on any of those? So we have some properties that you probably have already learned, but log base b of b. So we're saying b to some power is supposed to get us a b. Well, what's the power? 1. So if I have log base 18 of 18, my answer is just going to be a 1. Our next one says b to some power is supposed to get us a 1. What exponent can we raise things to that always turns into a 1? 0. So in this case, log base b of 1 is 0. It doesn't matter what the base is. If you're being asked to take the log of 1, you're always going to get 0. All right. Our next one says b to some power is supposed to get us b to the x. So what's our power? An x. So if our base matches the number being raised to the power, our answer is just our power. This next one is, the font we used isn't as clear as I'd like it to be, so I'm going to rewrite it here. We're really saying we have some base, we are raising it to a power that's a log expression. Okay? But again, if our bases match, so if the base in this log expression matches the base that's being raised to that power, we are back to just getting our x. Okay? So these last 2 rules that we just went through, we're really matching bases. Our answer will just be our x. And then what is the base if I just write the word log and I don't put any base next to it? What's implied? Anybody remember from last year? Nope, that's a different one. We're going to talk about that too, but it's not base E, it's base. Our whole number system is based on base. Base 10. So when we write log, it means log base 10. Okay, we often refer to this as common log. But if you see a log with no little base number written in there, it's implying a base 10. All right. All right, so we are looking at evaluating log base 7 of 7. So again, in our mind, we're asking ourselves, 7 to what power gets us a 7? Our answer is just a 1. Okay. Log base 5 of 1. The log of 1 is always 0. It doesn't matter what your base is. Log base 4 of 4 to the 5th power. Our answer is our power, right? 4 to what power gets us 4 to the 5th? Our answer would be a 5. All right, so I'm going to pause the video. I want you guys to try the last few. Checking our last few here. Log base 9 of 9. 1. 6 to the power, that's a log base 6 of 9. Again, if these two match, our answer will be this. Okay. The log of 1, any base would be 0. If there is no base, we said it implies base 10. So this would be log base 10 of 10 to a power. So what's my answer on this one? Just the x. And same thing here. This is log base 10. So 10 to what power gets me 1,000? So on the ones that we've done today, have we had to use a calculator for any of it? No. If I gave you log base 2 of 32, 2 to what power gets us a 32? A 5. So we would get an answer of 5, yes? If I said log base 2 of 16, you would say 4. If I said log base 2 of 20, more difficult? Why? It's not perfect, right? 20 is not one of our powers of 2. I can use some reasoning and say since 20 is in between 16 and 32, my answer is going to have to be somewhere in here between a 4 and a 5, right? But it would be a decimal number. For the ones that work out perfectly, we expect you to be able to do those without a calculator. Power charts are fine to have out, but you should be able to do these basic ones without a calculator. Okay? We'll learn ways to deal with the decimal ones later. So you guys are going to work on page 465, 1 to 42, 81 to 86, and 99 and 100. Again, most of these should go very quickly. Let me know if you have any questions.